Hi, today we're looking at NCFE Level 2 Functional Skills Maths. This is paper 001457 and we're going to start with the non-calculator section. So, question 1. Damon is a motorcycle racer. He takes part in 2 races over a weekend. 4,650 spectators watched the race on Saturday. This number increased by 2% on Sunday. Increase 4,650 by 2%. Right, we're increasing it by 2%, so we're going to work out what 2% of this is and then add it onto the original. Okay, so, 4,650, that represents 100%. So what we're going to start off is we're going to work out what 1% of 4,650 is. Well, when it's 100%, it's all of this. So if it was 10%, we would just take a 0 off, or would move the decimal point in 1. Because it's 1%, we're dividing by 100, so we're going to move the decimal point twice, which would give us 46. If we imagine the decimal points moved to here, we'd have 46.5. We want 2%, so that's going to be double this amount, because 2 is double 1. So we can double it, we can multiply it by 2, or we can just add another 46.5 on, because that's going to give us 2 of them. So it doesn't matter, times 2, add it twice, same thing. So 5 plus 5 is 10, put a 0, carry the 1, make sure we've got a decimal point brought down. 6 plus 6 is 12, plus 1 is 13. So 3, carry the 1. 4 plus 4 is 8, plus 1 is 9. So we've got 93 spectators. That's the 2%. So we need to add that back onto the original. So we've got 4,650. And we're going to add on 93. So 0 and 3 is 3. 5 and 9, or start with the bigger one. I think 9 plus 5. We'll start with 9. It's going to be 10, 11, 12, 13, 14. So 4, carry the 1. 6 plus 1 is 7. 4 plus nothing is 4. So we've got 4,743. One B. In the race on Saturday, each lap was 2.678 miles long. 1 kilometre equals 0.6214 miles. So 1 kilometre is more than a mile. Good to think of it like that. Help me get these round the right way. Round each of these 2 figures to 1 decimal place. Use these values to estimate the length of the lap in kilometres. Okay, so we're going to round them to 1 decimal place. Well, let's start with this one. So 1 decimal place, the first decimal place is the first number after the decimal point, which is a 6. So we look at the digit after that. And we say, well, if it's less than 5, we just keep it as a 6. If it's 5 or more, which it is, we need to increase this by 1. So that's going to make that 2.7. Okay. Now, we need to round this number as well. Again, it's to 1 decimal place, so that's the first decimal place. We look at the digit afterwards, which is this 2. It's less than 5, so that's just going to stay at 0.6. Okay. Now we're trying to use these values to estimate the length of the lap in kilometres. Well, if we know that 1 kilometre is 0.6 miles, well, we're starting with 2.7 miles. So we want to know how many kilometres that is. So we need to divide 2.7 by 0.6. Because if 1 kilometre is 0.6 miles, we want to know how many 0.6s are in here. So we can say 2.7 divided by 0.6. That's probably the hardest bit, doing that step there. Okay, now you might think 2.7 divided by 0.6 is quite hard, but what we can do is we can actually multiply both of these numbers by 10. And what that will do is, or if you think of 2.7 divided by 0.6, it's like 2.7 over 0.6. Now you'll see why this is helpful. If we multiply both numbers by 10, well, that's going to move the decimal point over there, so we're going to get 27. Move that over there, and we're just going to have 6. So 27 over 6 means exactly the same thing, but suddenly that's going to be easier to work out because we've got 27 divided by 6. Well, we can do that using the bus stop method. So saying how many times does 6 go into 27? Well, 6 into 27, you've got 6, 12, 18, 24, 30 is going to be too many, so it's just going to be 4 times. Okay, but what we can do is we can put 0. And that means that the 3 we've got left over, so 4, 6 are 24, so 25, 26, 27. So we've got a remainder of 3. We can carry that over in front of the 0. So if we put our decimal point in, and now we say how many times does 6 go into 30? Well, 6, 12, 18, 24, 30. That's 5 times. So we've got an answer of 4.5 kilometres. One C. Damien and Ralphie each complete 7 laps in the race on Sunday. The median lap time for Damon is 1 minute and 17.924 seconds. This is shown as 1:17.924. The range of the lap times for Damon is 4.812 seconds. The table below shows the lap times for Ralphie. Calculate the median and the range of times for Ralphie. Right, so if we want the median, that means that's the middle time or middle number. So the best way to do that is to rank them first. So it's the middle number when you've got them from smallest to largest. So which is the smallest number? Well, they've all got 1 minute at the front. So we can kind of ignore the 1 and look at the second. So this is 21, 19, 17, 16. We've got another 16, 17 and 18. So these are the 2 smallest because they're both 16. This is 16.0. This is 16.8. So this is our smallest. That's our next smallest. Okay. Then we look at the next smallest. So we add 121, 119, 117. We've got another 117. So this is 17.9. This is 17.8. So this is the next smallest. Then it's this one. Then we've got 21, 19 and 18. So then it's going to be 18 and 19 and then the 21. Okay. So what I'll do, I'm going to write them all out in full. So we've got 116.810. Yeah, I'll do all of it. Sorry, it was this one, wasn't it? 116.008. Then we've got 116.810. Then the third one is 117.841. Then 117.986. And fifth is 118.462. Then 119.148. And then finally 121.467. So we cross off the smallest and largest, keep going in pairs until we end up with 1 in the middle. So the median is 117.986. We want the range as well. Well, the range is the biggest minus the smallest. Well, the biggest one is going to be this last one. So 121.467. And we want to take away the smallest, which is 116.008. Well, 7 minus 8, you can't do because 8 is more than 7. So we take 1 from the 6, reduce it to 5, and pass the 1 over. 17 minus 8 is 9. 5 minus 0 is 5. 4 minus 0 is 4. 1 minus 6 we can't do again because 6 is bigger than 1. So reduce the 2 to a 1. Give 1 there to make that 11 minus 6, which is 5. 1 minus 1 is 0. And 1 minus 1 again is 0. Okay, so our range is going to be 5.459 seconds. Okay. It then says use these values to make 2 comparisons between the 2 racers. Okay, so we know that actually we want to have up here, we've got the median time for Damon. So what we can say is well, which is bigger? So we've got a median of 117.924. This is a median of 117.986. So for Damon, I keep saying Damon. Damon has a smaller median, which means a quicker lap time. So we're trying to convert it not just using numbers, but what that actually means in real life. So smaller number means he's quicker. Okay. Now if we look at the range, who had Damon has 4.812 and Ralphie has a range of 5.459. So we can say Damon also has a smaller range, so his lap times are more, and this is the key word, more consistent. If you've got a smaller range, they're more consistent because it means the values are closer together. Okay. Right, and we can have a look at 1D. Damon drives along a straight part of the track at an average speed of 126 miles per hour. He completes this in 47.5 seconds. Work out the length of the straight part of the track in miles. The speed that you're travelling times the time that you're travelling at that speed is going to tell you how far you're travelling, or the distance. And you might remember it with a handy little triangle like this. So in other words, we're saying the distance is equal to speed times time. Now this is helpful because this also means if you want to work out the speed, then you know it's distance divided by time. Or if you want to work out the time it takes, then it's the distance divided by the speed. Okay, we're trying to work out the length, so that does mean that's the distance, so it does mean we want speed times time. Now let's say we've got the speed in miles, but our time currently is in seconds. So what we can do is we need it all in the same measurements. Our speed, this is 126 miles per hour, and the time is 47.5 seconds. Okay, so we want to say, if we're working out the distance, we want speed times time. So we know that there are 60 minutes in 1 hour. So if we do 126 divided by 60, that's going to give us, well actually let's work that out. So what we can say, 126 divided by 60. Well, let's do 126 divided by 6. We're going to ignore the 0 for now. So how many times does 6 go into 1? Doesn't go. 6 into 12? Well, 6, 12 goes twice. How many times does 6 go into 6? Well, that's once. Now it's 126 divided by 60, not just 6, a bigger number. So we need to put a decimal point in there. Okay, and if you look at it, that makes more sense as well, because you think, well, 2 lots of 60 would be 120, so 2.1 is going to give us this value here. Okay, so we're putting the 0 back in, bringing in the decimal point. Okay, so we've got 2.1 miles per minute. Okay, it's not how we normally write it, but miles per minute, we can keep that in there. So now if we want to turn it into miles per second, well, we're going to need to divide the 2.1 by 60. So 2.1 divided by 60. Okay, again, that's going to be a slightly strange thing to do. We can try and do it with the bus stop method again. And I'm going to ignore the 0 again, but I'm going to put the decimal point in, because I think it gets too confusing if you take everything out completely. So how many times does 6 go into 2? Doesn't, so we carry the 2 over, keep the decimal point. How many times does 6 go into 21? Well, 6, 12, 18, 24 would be too many, so it goes 3 times for 21. Sorry, for 18. And then 19, 20, 21. That means we've 3 left over, or remainder 3. So we'll put our 0 here, so we've got somewhere to put the 3 in front. How many times does 6 go into 30? 6, 12, 18, 24, 30. So that's 5 times. So what all of this is saying is that 126 miles per hour is equal to 0.35, and I'll write it all out, miles per second. Okay, so we've divided it by 60 and divided it by 60 again. So miles per second. Now, if he's travelling for 47.5 seconds, well, we've now, we had this in miles per hour, we've now got this in miles per second, so we can multiply these two together. So what we want is 0.35 times 47.5. Now we've still got a, what have we got here? We've still got something to put back in that I nearly forgot. This was dividing it by 60 originally, not 6. So if we put the 0 in there, we actually need to move that decimal point across. So our answer, so I nearly missed it, is actually 0.035. Let's put that in there. 0.035 miles per second. Okay, so we've got to multiply 0.035 times 47.5. But we're still in the non-calculator section here, so we can't just type that in. So this is a little bit trickier. What we're going to do for this multiplication, ignore the decimals completely. Although when we're ignoring things, like I ignored this 0 here, we've got to remember to put them back in afterwards. So if we ignore all the decimals, that means we've got 35 multiplied by 475. Okay. 5 times 5 is 25. 5 times 7, 5, 7, 7, 14, 21, 28, 35. Add on 2 gives us 37. Carry the 3. 5 times 4, or 4 times 5, 5, 10, 15, 20. Add the 3 to give us 23. Now we come on to the 3, the 10s, so we can put a 0 here. So 3 times 5, 5, 10, 15. 5 carry the 1. 3 times 7, 7, 14, 21. Add on the 1 to make it 22. And then 3 times 4, 4, 8, 12. Add the 2, makes it 14. Okay, so we're going to need to add these all together. 5 plus 0 is 5. 7 plus 5 is 12 to carry the 1. 3 plus 2 is 5 plus the 1 is 6. 2 plus 4 is 6. 1 plus nothing is 1. So 16,625, but now we've got to put these decimal points back in. So if you look with this one, we had 1, 2, 3 decimal places. With this, we had 1 decimal place. So 3 decimal places and 1 decimal place. In total, that's 4 decimal places we've got. So we've got our decimal point here. We've got to move it 1, 2, 3, 4. So we've actually got 1.6625, and this is distance, and we're working in miles. So that's our answer. In fact, we can put that in here. Question 1E. Damon is paid by 3 companies to advertise their brands on his race suit. 2/3 of the adverts are for company A. 1/7 of the adverts are for company B. The rest of the adverts are for company C. What fraction of the adverts are for company C? Well, what we can do is if we add these two together and the rest, so in other words, if we then take that answer away from 1, that would be our answer. Okay. Or if you think of it in terms of percentages, say this was 60% of the adverts were for company A and 10% were for company B. Well, in total, that would be 70%, and the leftover bit, the 30%, must be for company C. So we're doing it a similar way, but we're doing it with the fractions. So the first thing we want to do is add the 2/3 plus the 1/7. Okay. Well, we can't add fractions unless the denominators are the same. Okay, so we first say, are they the same? No, they're not. Does one denominator go into the other? Well, 3 doesn't go into 7, not without a remainder anyway. So we're going to need to change the denominator on both of them. We want a number that 3 and 7 both go into. Okay, so a common multiple, a number that's in the 3 times table and the 7 times table. And the easiest way to do that is to multiply them together. So 3 times 7, 7, 14, 21. So our denominator is going to be 21. So I can put it just one denominator because it's going to be the same for both. And we say, well, how many times did 3 go into 21? Well, we multiplied it by 7, didn't we, to get to 21. So if we've done that to the bottom, we need to do the same to the top. So 2 times 7 is going to give us 14. Okay, so we've kind of rewritten this fraction 2/3 as 14 over 21. We're going to do the same with this fraction. We'll say, well, 7 has been replaced by 21. And that's because we multiplied it by 3. So we've got to do the same to the top to keep the same value of the fraction. So 1 times 3 is 3. So with this, what we're saying is 1/7 is the same as 3 over 21. But the benefit of doing this is that now they've got the same denominator. So we can just keep that denominator and add the numerators. So we've now got 17 out of 21. Okay. So if that's the fraction of the adverts for company A and B altogether, well, if we want to know what's left for C, well, if it's 17 out of 21, well, we just need to do 21 minus 17, and we can count back, or we can count up from 17, 18, 19, 20, 21, 4. But it's not just 4, it's 4 21s, or 4 over 21. 1F. I'm going to put commas in here because I find it much easier to read, especially these big numbers. So if you want to put commas in to make it easy to read, start from the far right and go 1, 2, 3, comma, 1, 2, 3, comma. So now I can read this much better. 1,540,806 people followed Damon on social media last year. This number increased by 674,957 people this year. Work out, and again, I'll put all the commas in, 1,540,806 plus 674,957. So we can do this using the column method, making sure that we line up our units. So you can even write the number backwards. So we're lining up the units, the tens, the hundreds, the thousands, the tens of thousands, and the 100,000s. So 6 plus 7 is 13, 3 carry the 1. 0 plus 5 is 5, plus 1 is 6. 8 plus 9 is 17. 0 plus 4 plus 1 is 5. 4 plus 7 is 11. 5 plus 6 is 11, plus the 1 is 12. And 1 plus 1 is 2. So we've got 2,215,763. And now we're on to the calculator section. Question 2a. Fiona is on a work placement in a hotel. The hotel has a loyalty program for the guests. There are 3,400,019 guests currently signed up to the loyalty program worldwide. Write 3,400,019 as a number. So this is where I find it really helpful to use the commas. So 3 million, so 3 for the million, I put a comma. 400,000, so 400, and I put a comma for the 1,000, and 19. Well, if we just put 19, that doesn't quite look right, because we should have 3 numbers before each comma. But if you think, what's missing? Well, we haven't got any hundreds. Excuse me. So we need to put a 0 in here to show we've got no hundreds. And by having the comma there, it made it obvious that something was missing. So it was easier to spot. Okay. (2b). There are 216 guests currently staying at the hotel. 81 of these guests are signed up to the loyalty program. Fiona thinks that more than 4/10 of these guests are signed up to the loyalty program. Is she correct? Okay, well, what we can do is we can find out what 4/10 of 216 is to tell us how many guests would expect to be signed up and compare it to 81. So 4 divided by 10 times 216. Now we can use our calculator. 4 divided by 10 times 216 gives us 86.4. Well, that's more than 81. So, no, she's not correct. Because she's saying she thinks it's more than 4/10, but if it was 4/10, it should have been a bigger number. There's a different way of doing this. What you can actually do is say, well, let's see what fraction this is. So we can say 81. So let me just do a line here. So this is an alternative. We could say 81 out of 216. And we'll see that we get 0.375. And actually, if we do 4/10, or do 4 divided by 10 to get that as a fraction, as a decimal, you'll see that 0.375 is less than 0.4. So we can see that, again, she thought that it'd be 4/10, but it's less than that. So either way you want to work with it, I think the first way we did it is clearer, but there is an alternative. (2c). The table below shows information about the 216 guests staying at the hotel on Sunday. So there were 59 guests that stayed for 1 night, 42 guests that stayed for 2 nights, and so on, and a total of 216 guests. Every Sunday and Monday, guests who will be staying for more nights than the mode are given a voucher for £10 off food and drink in the restaurant. We need to turn over for the question. The total value of the vouchers given to guests on Monday was 4% more than the total value of the vouchers given on Sunday. What was the total value of the vouchers given on Monday? Right, so let's go back and work out what we have to do. So it says, every Sunday and Monday, guests who will be staying for more nights than the mode are given a voucher for £10 off food and drink in the restaurant. So we're interested in how what's the value of these vouchers? And to know that, we need to know the guests will be staying for more nights than the mode. So what's the mode? So the mode is the most common. So it's going to be the number of nights with the biggest number. Well, the biggest number here is 65. So the actual mode will be 3. So more people stay for 3 nights than any other number of nights. Okay, so the number of people that stay for more than the mode is going to be 25 and 16 and 5 and 4. So the people that stayed for 4 nights, 5 nights, 6 nights and 7 nights. So in total there were 25 plus 16 plus 5 plus 4. So there were 50 guests. Stayed more than mode. Okay. And each of them get £10. Okay, so we can easily say, well, 50 times 10, we add a 0 on, is going to be £500. Okay. Now, the question said the total value of the vouchers given to guests on Monday was 4% more than the total given on Sunday. So we need to increase this by 4%. Okay, so what we can say is, well, let's work out what 4% of 500 is. So we want 4 out of 100 times 500. So we can do 4 divided by 100 times 500. So that's £20. And then if we add that onto the original, which was 500, well, you can see we're going to get £520. (2D). Fiona uses this formula to work out the number of loyalty points earned by each guest last year. And we've got L equals 300. And then we've got brackets, so we've got an invisible times there. So 300 times S plus R over 2, or R divided by 2. And we're told that L is the number of loyalty points collected in a year, S is the number of nights stayed in a suite, and R is the number of nights stayed in a regular room. She then uses this table to put each guest into one of 5 tiers based on the number of loyalty points they earned. So they're in tier 1 if they earn up to 599 points. If they earn between 600 and 1,499, they're in tier 2, and so on. Last year, Mrs. Jones stayed 3 nights in a suite and 7 nights in a regular room. Which tier should Fiona put Mrs. Jones into? Right, well, we're going to need our formula. So we can replace these letters with the values now. So we're going to have 300. And we said we're going to put in the multiply, even though we don't have to have it. I think it makes it easier. The S, what's the S represent? Number of nights stayed in a suite. Well, she stayed for 3 nights in a suite, so we've got 3 there. And R, number of nights stayed in a regular room. She stayed for 7 nights in a regular room, so 7 over 2. Okay, well, we need to do what's in the brackets first, but even within the brackets, we've got 2 bits. We've got an add and we've got a divide. So the D in bid mass comes before the A, so we're going to do the divide. But everything else still stays. So we've still got the 300, we've still got the times, we've still got the 3 plus, but this is the bit we actually have to work out. Okay, and we can use our calculator here. So we're going to say 7 divided by 2 gives us 3.5. Okay? Now, BidMath would say, well, multiplication, but remember we've still got brackets here, so we need to do what's in the brackets first. So we still keep the 300 because we're not doing anything with that yet. But we do need to add 3 to the 3.5 to get 6.5. Now we can multiply our 6.5 times 300. We've got 1,950 points. So where's that going to fall? Well, it's more than 1,499, but it's less than 2,999. So it's going to go in this category, which is tier 3. So we can put 2E. A luxury room in the hotel has a bathtub 60.3 inches long. What is the length of the bathtub in centimetres? Use the conversion 1 inch equals 2.54 centimetres. Okay, so if we know that 1 inch is 2.54, if we've got 60.3 inches, well, we need to multiply that by 2.54. So think the centimetres, we've got more centimetres than inches, so we need to make this number bigger, so we're going to multiply it. So we start with our 60.3. Try and lose that reflection there. 60.3 times 2.54. 153.162 centimetres. It says, give your answer correct to 1 decimal place. Well, that's the 1 decimal place. So look at the next digit. It's more than 5, so we're going to have to round it up to 153.2 centimetres. Question 2F. Fiona helps with organising an event at the hotel. The diagram below shows the dimensions of the dance floor. The shape of the dance floor has one line of symmetry. Right, so let's have a look at it. Okay, so looks like our line of symmetry there, because this would perfectly match onto there. So we've got 17 metres across here, 20.5 metres at the widest point, and then back to 17 metres, and the full length is 23 metres there. On the dance floor, each person must have at least 0.9 metres squared of floor space. Work out the maximum number of people who can use this dance floor at one time. Right, so what we want to know is what's the area of this dance floor. So it's a slightly odd shape, but what we can do is, well, if we split this shape where they've drawn this line, well, I know that this shape here, it's got 1, 2, 3, 4 sides. It's got one set of parallel sides, so this is a trapezium. And I know the formula for the area of a trapezium is half times a plus b times the height, where a and b are the two parallel sides. So we've got half times, we can replace these with 17 and 20.5, and the height is going to be this distance. Okay, this is our height, this is h. Well, we know the full height is 23 metres, and because this is a line of symmetry, it's going to cut it in half. So h is going to be 23 divided by 2, which gives us 11.5 metres. Okay, so we're going to keep a half, because what we want to work out first is the bit in the brackets. Well, 17 plus 20.5 gives us 37.5, and then we're going to multiply it by 11.5. Okay. So a half, if you know it is a decimal, you can go straight to 0.5, but 1 divided by 2 is 0.5. Multiply it by 37.5, multiply it by 11.5, and you get 215.625 metres squared. Now that's for one trapezium. We want 2, and because we've got a line of symmetry, we can just multiply it by 2. which gives you 431.25 metres squared. Now what you could, I did it this way because I thought it was clearer to work out the area of one straight away, but if you think, well, I want two of them, we were multiplying by half here. We could have actually said, well, if I'm multiplying it by 2 as well, I cancel it out. So we could have gone straight to 431. But if that's not clear, ignore that. We worked out the area of a trapezium and then doubled it to get the area of the dance floor. Right, so we've got the area. We want to know how many people we can fit on there. Well, if each person needs 0.9 metres squared, we want to know how many 0.9 metres can we fit in 431. Or in other words, 431.25 divided by 0.9. And we get 479.166666. But of course you can't have 0.166 of a person, so we're going to have 479 persons or people. Question 3a. Callista is a product designer at a toy factory. The diagram shows a metal part in a toy robot. What is the name of this shape? Right. If you know what it is, then these questions are easy. If you don't know what it is, then you can use a process of elimination and knowledge of what you do know. So if you're struggling, you can think, well, maybe think cuboid. Cuboid is like a cube, but instead of all the faces being squares, you can have rectangles in them. Well, we got triangles in here, so it's definitely not going to be a cuboid. What about a cylinder? Well, a cylinder is like a can of Coke. You've got a circle in it. We've not got any circles here, so it's definitely not a cylinder. Pyramid, well, if you think of like ancient Egypt, a pyramid usually looks something like this. You might have something like that. Well, it's not a pyramid because we'd have a point at the top for a pyramid, but we got 2 points. So it must be a prism. If you know it's a prism and you remember, well, a prism just means we've got a cross section, or we've got the one shape which is the same all the way through the shape. Okay. So either way, you can get to the right answer. (3b). Callista designs a plastic piece for a game. The piece is in the shape of a cone. The diagram shows the dimensions of the piece. So we've got it here. So we're saying this height is 24 millimeters. The radius of the circle down here is 7 millimeters. Move this up. They are asked us to work out the surface area of the piece. So that's the area around the cone at the top and this circle at the bottom. And it said use A equals pi r squared plus pi rs, where A equals the surface area of a cone, so that's what we're trying to work out. R is the radius of the circular base, so this distance here, and S equals the slant height of the cone, which is this distance here. And they've told us to use pi equals 3.14. So they've given us all the numbers, so we can just write out the formula, 3.14, but instead of the letters, we can replace it with the numbers now. And remember, when you've got a symbol or a letter next to a number or anything together, there's a missing multiply sign. So r squared, so r is 7. Squared means you multiply it by itself, so 7 times 7. And then we've got another pi, 3.14, times r, which is 7, times s, which is 24. So I'm going to work these out as two separate bits. So this first bit here, we've got 3.14 times 7 times 7. So we've got 153.86. And over here we've got 3.14 times 7 times 24, which is 527.52. So if we just add these together, get 681.38. And in fact, they've given us the units to use down here, which are millimetres squared. There we go. C. Callista mixes 3 colours to make teal coloured paint for the plastic game pieces. She mixes blue, green and yellow paint in the ratio 4 to 2 to 1. Callista wants to make 14 litres of teal coloured paint. She thinks she needs 1.6 litres of yellow paint. Is she correct? Right, well, whenever we get ratios, we should draw a table. And we've got 3 ratios in it, so we're going to want 4 columns. Because we're going to want blue, green, yellow, and we'll want a total column as well. So every time we've got 4 litres of blue paint, we need 2 of green, 1 of yellow. So if this is all we had, 4 plus 2 plus 1, we'd have a total of 7. But she wants to make a total of 14 litres. Well, how do you get from 7 to 14? Well, 14 divided by 7. Hopefully you'll know this, but we can do it on the calculator. 14 divided by 7 gives us 2. So in other words, we're doubling everything. So we can double this to give us 8 for blue, double this to give us 4 for green, double this to give us 2 for yellow. We only needed to do the yellow one, but it's good to do this for completeness, because then we can say, well, 8 plus 4 plus 2 equals 14. So I know I've done it correctly. She thinks she needs 1.6 litres of yellow paint. We've got 2. Well, 1.6 is less than 2. So is she correct? No. She's incorrect. (3D). The graph below shows the information about the settings and fault rate of a machine in the toy factory. Okay, so let's have a look at this. We've got the fault rate, number of faulty toys per 1,000, and we've got the machine setting, which is number of toys made per hour. So what this is telling us is machine setting. So one we had number of toys. So when we had the machine set to make 1,000 toys per hour, on one instance we had, what's this, halfway here. Actually, let me pick one that's easy to explain, and then I can. Oh no, let's stick with this. Well, what we can say, if we know that this is 10, we've got 1, 2, 3, 4, 5 squares in here. So 10 divided by 5 means that each of these little squares is worth 2. So that's actually 1. So what this is saying is that there was an instance where the machine setting was for 1,000 toys per hour, and the fault rate was 140 toy per 1,000. Okay. We also had another instance where the machine was set for 1,000 toys, and we had 440 toys for every 1,000. Okay, and you can see that as the setting is set for more toys per hour, it looks like that you're getting more faults because it's going up. Okay. And they've asked us, what was the highest fault rate when the machine was set to make 1,600 toys per hour? Right, okay, 1,600. Well, this is 1,500, and we've got 2,000 here, so each of these must be worth 100. Because this would be 1,600, 1,700, 1,800, and so on. So we're interested in these. And the highest fault rate, well, it would be this one at the top, which is 20. So our answer is just going to be 20. So we've got the same graph again. The graph below shows the information about the settings and fault rate of a machine in the toy factory. Yeah, exactly the same graph, but we're going to get a different question now. It's here. Callista is writing a report. She uses a line of best fit to find the fault rate when the machine setting is 2500. Callista writes, the fault rate when the machine setting is 2500 as a percentage of the median fault rate when the machine setting is 2600 is more than 90%. Is she correct? Show how you decide. Right, complicated, but it doesn't have to be. But we're interested in the machine setting is 2500 and 2600. So that means we're looking at this, and I'm actually going to draw a line straight up. So that's 2500, and this would be 2600. Okay. Right, so we can move it down now. And what it said, let me remind you, hopefully you can kind of go back in the video and look over this, but what she was saying, she uses a line of best fit. Well, let's draw a line of best fit on here to start with, okay? So a line of best fit is a straight line that goes right through the data, follows the overall pattern, so in this case it's going to be going up, and it has roughly the same number of values above it as below it. So it's a bit awkward, this one, because if I do the line just down here, I'm sort of ignoring these higher ones up there. So maybe you want to have it a little bit steeper. Something like that. Okay, so if the line goes through any of the values, that's fine. But also, if it doesn't go through them, that's fine as well. It might be slightly high, but I think that's okay, because we're trying to get these ones taken account of as well. Okay, doesn't have to be perfect. There's going to be more than one right way to draw a line of best fit. Okay, so she uses a line of best fit to find the fault rate when the machine setting is 2500. So when it's 2500, it's, well, 2500 actually is right there. Remember, if each of these boxes is worth 2, well, that's going to be 44. Okay, and the fault rate when the machine setting is 2500 as a percentage of the median fault rate when the machine setting is 2600. Well, so what she means by that is 2600, we had 3 values. The median is going to be the middle one. Well, this median one here, well, if this is 44, that's going to be 46. It's going to be 48. Okay. So what we're going to need to do with this one is say, well, we've got 44 as a percentage, so it's going to be 44 over 48 times 100. What's that going to give us? $91.66. Well, let's round this to the nearest percentage, because they were talking about 90%. Well, actually, we can keep it as 91.6, blah, 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 because the important thing is that that is more than 90%. She said the fault rate when it's 26,000 is more than 90%. Well, looking at this, yes, it is. So yes, she's correct. Now, depending on how you draw your line of best fit, you might get a slightly different answer. Okay, so let's say if I'd drawn my line a bit further down like this, I'd get slightly different values. Now, there's no perfect way. You just try and get your line of best fit as good as you can. And when they're marking this, they're going to be looking at values, like a range of values that are acceptable. If you're outside that range, then you might lose that mark, but you will still get method marks for working out sort of how you're doing your comparisons basically in the other bits. Okay, so it's not the end of the world if you do lose a mark here. Just try and do the best you can, and remember there's more than one mark to be had. So 3F. Callista has this data about the volume of plastic used to make the toys she has designed. So 26,000 toys used a volume of plastic between 0 and 30 centimetres cubed. Okay, for 42,000 it was more, and you get the different values for the different number of toys made. She works out an estimate of the mean volume of plastic used for each toy. She wants to reduce this mean by 8%. If she is successful, what will the new mean be? Right, well, if we want to know what the new mean is, we need to work out what the old mean is first. Whenever we're working with ranges, we don't know exactly what values these are referring to. So it could be 26,000 toys that used exactly 30 centimetres cubed of plastic. It could have been that some of them used nearly nothing, some used 10, some used 20 in this range. So what we do, this is the estimating bit. We say, well, I'm going to assume that for each of these ranges, the values were right in the middle. And so the way that we find what that midpoint is, the middle part of that range, is by taking the lowest bit, the 0, add the 30, and then divide it by 2. So we're finding the halfway or midpoint. So again, for this range, we're going to do 30 plus 60, divide it by 2, we get 45. So this is saying that 42,000 toys were made with 45 centimetres cubed of plastic. Okay. So again, for the next range, 60 plus 90, divided by 2, 75. 90 plus 120, divided by 2, 105. And 120 plus 150, divided by 2, is 135. Now, if you remember, when we're working out the mean, it's the total divided by the frequency, or how many. Now, the total in this case is the total amount of plastic used. Well, the 15 just refers to if we only had one toy, but we actually had 26,000. So if we want to work out the total amount of plastic for each range, we first of all need to work out how much plastic was used for each of these ranges. So in this range, it's going to be 15 centimetres cubed of plastic times 26,000, because there were 26,000 toys. So for each of these, we're going to be multiplying the values together. Okay, so if we do 26,000 times 15, we get 390,000. For 42,000 times 45, we're going to get 1,890,000. 1,890,000, yeah. Okay. Now, what you could do with this, because we're getting very large values, we could have worked in thousands. So we could have ignored the thousands and just said this is 26, this is 42. And we just need to remember to put the thousands on afterwards. I'm not going to do that in this case. I'm going to keep them there. Doesn't really matter which way. I'm just doing it this way so I don't have to remember to do anything special afterwards. Right, so if we add this up, this will tell us the total amount of plastic used for all of the toys. So 390,000 plus 1,890,000 plus 1,275,000 plus 945,000 plus 810,000. But this is where you can go wrong when you're doing all these thousands. It's very easy to put one too many or too few zeros. And we've got a total of 5,310,000. It's going to go off the page, centimetres cubed of plastic. Okay. So that's our total. The frequency, well, how many toys are there? Well, there's 100,000. So we're going to want 5,310,000 divided by 100,000. But I've still got that total in my calculator. Divide it by 100,000 and we get 53.1 centimetres cubed. Now she wants to reduce this by 8%. Okay, so we could work out what 8% is and take it off, but I'm going to do a shortcut. I'm going to say, well, if we're reducing it by 8%, well, 100% would be all of it. If we're reducing it by 8%, we want to work out what 92% is. So we can say 92%, or 92 over 100, times 53.1 gives us 48.852. They've asked for it to one decimal place, so again that's the one decimal place. We've got a 5, so we've got to round it up. So it's going to be 48.9, and that is centimetres cubed. 4a. Abdul wants to build an extension to his house. The coordinate grid below shows the plan of his back garden where the extension will be. Move this up. Points A and B are two corners of the extension, to here and here. Let's move it up further. The line AB shows one wall of the extension. Right. The floor of the extension will be a square. Write down a set of possible coordinates for the other two corners of the extension. Right, what if it's a square? Let's see how long the side's going to be. So 1, 2, 3, 4, 5. So the extension can either go up this way or down this way. I'm going to come down this way, I think. 1, 2, 3, 4, 5. So we could have a corner there and another corner there. So we want the set of possible coordinates for the other two corners. Well, if it's here, we always have the x coordinate first. So the x coordinate is the 4. The y coordinate is 0. And the other coordinate is this one here, the 9. So it's 9, but it's still a 0 y coordinate. So 9, 0. So if you wanted to do yours up here instead, where would it be? 1, 2, 3, 4, 5. Here and here, that's fine. I'll just mark them on. You would end up with 410 and what would we have? 910. Okay, but you don't need both. You can do one set. So either this set down here or this set up there. (4b). The diagram shows the shape of the extension. This is the front view, so we're looking at from there. Draw the side view and the front view of the extension. Well, if that's the front view, the side view is going to be there. And we haven't got a scale or measurement, so we just got to do it roughly. So what we know is that this side is higher than this side, and the length looks longer than the height. So I'm just going to draw this out to around here. Let's say we know this wall over here isn't as high as the other one, and we've got a sloping roof. Yeah. So that's going to be fine for my side view. The front view, well, the front view is looking here, so we're going to have a rectangle. Okay. Now the thing with this, I've drawn a rectangle here, so that's if we're looking here. So we would see this rectangle, but actually we would see the top of this sticking up as well, but we'd have this line separating it. So we'd have this little bit that we would see. So it's not as tall as this bit, but there is an extra little bit. So for my rectangle down here, I'm going to extend it slightly, just a bit. Because we would see that back bit. So this would be the front, but we'd see the back bit sticking up as well. (4C). The diagram below shows the dimensions of the extension. So we've got it's coming out by 6 meters. We know it's square, so it's 6 meters across as well. The height on the shorter wall is 2.5 meters, and on the higher wall it's 3 meters there. Abdul wants to work out the power of the heater needed for the extension. First, he needs to find the volume, V, of air inside the empty extension by using this formula. And we've got the V equals 0.5 times W times L times A plus B. Where A is the greatest height, so that'd be the 3 meters. B is the smallest height, 2.5 meters. W is the width, and L is the length. And because they're the same, it doesn't matter which is width, which is the length. They're both going to be 6. Okay. Now if we turn over, we can see what the actual question is. And it says, Abdul then uses this formula to work out the power of the heater needed for the extension. And the power is P equals 40V plus 100N, where P equals the power of the heater, V equals the volume of the air inside the empty extension, and N equals the number of windows. There will be 2 windows. Work out the power of the heater needed for Abdul's extension. Right, well, we need the volume, so I'm going to turn over. I'm going to work out the volume on here first, and then we'll go and do the other bit afterwards. So the volume is 0.5 times W. We said treat that as the width, the length, treat that as the length, and A plus B, we said A is the greatest height, so 3 plus 2.5. So let's do this one bit at a time. I'm going to repeat all of this 0.5 times 6 times 6. I'm not working any of that out yet because we've got to do our brackets. So 3 plus 2.5 gives us 5.5. Now we can multiply all these together. So 0.5 times 6 times 6 times 5.5 equals 99 meters cubed. Okay. So now we're going to carry that over to here. So we know that V equals 99 meters cubed. So we've got 40V, so 40 times 99. And then we're adding 100 N. N's the number of windows, which is 2. So 100 times 2. So 40 times 99 is 3,960. And 100 times 2, hopefully you don't need your calculator for that, we've got 200. So 3,960 plus 200 gives us 4,160. We can put W because that's going to be watts. (4D). Abdul needs to make a planning application. He must include a scale drawing of the garden and the extension. The width of the garden is 11.8 meters. The drawing will use the scale 1 to 200. Abdul thinks that the width of the garden in the scale drawing is 5.4 centimeters long. Is Abdul correct? Show how you decide. So with the scale, what it's saying is that 1 centimetre on the drawing would be 200 centimetres in real life. Okay, so what we're going to do here is we're going to work backwards. So we're going to turn our metres here into centimetres using the scale. But first, we need to work out how many centimetres this is in real life. Okay, so we know that we've got 100 centimetres in 1 metre. So if we do 11.8 times 100, we've got 1,180 centimetres, and I'm going to put real life. Okay, now we want to use the scale, so we want to divide it by 200 to find out how many centimetres it would need on the drawing. So if we divide it by 200, we get 5.9 centimetres, and I'll put on drawing. Okay, well, that is not equal to 5.4 centimetres, so is Abdul correct? No. He's incorrect. For E. Abdul finds this information about planning applications to his local council in 2020. We've got the type of planning application, so they're either major, residential or commercial. For the major ones, they received 270, 195 were granted and 75 were declined. And you can see the same types of numbers for residential and commercial. Abdul thinks that overall, residential applications are more likely to be granted than commercial applications. Is he correct? What we can do is we can work out percentages to compare them. So if we start off with residential, how many were granted? 267 were granted out of 306. If we then multiply that by 100, we're going to get a percentage. Oh, what did I do wrong? 267 divided by 306 times 100, and we get 87. I'll just do it to the nearest percent. 87%. Okay. We're comparing with commercial properties. Now I've rounded it to the nearest percent because I think that's going to be fine. If we end up that they've got the same percent, well then I'll do it again and I'll round it to a higher degree of accuracy, but I'm hoping this will be enough. For commercial, it was 94 granted out of 124. Again, we'll multiply it by 100 to get a percent. So 94 divided by 124 times 100, 75.8. So we'll round it to the nearest percent, 76%. Okay. He thinks residential are more likely to be granted. Is he correct? Yes, he is. Because we had a higher percentage granted than we did for commercial. Question 4F. Abdul finds this information about planning applications to his local council in 2020. So the same numbers we saw before. What's the probability that one of these applications chosen at random is a declined commercial application? Right. Well, let's think about the denominator. The denominator is going to be the total number of applications, which is going to be all of these received ones added together. So 270 plus 306 plus 124, so 700. So it's going to be out of 700 total applications. And it says the probability that one of these chosen at random is a declined commercial application. Well, these are the declined, these are the commercial, so 30 are the declined commercial. So we can keep it like this because it hasn't asked us to simplify it, but I can cancel the zeros if I want and say, well, it's just 3 out of 70. 4G. Abdul is granted planning permission. He does this calculation to work out how much concrete to buy. What answer should Abdul get? Right, so they want us to use bid mass for this. So again, just do it one step at a time. Don't try to do too much in one go, because that's when we can make mistakes, and then you can lose your working marks as well. So bid mass, we'll do the brackets first. So in the brackets, we've got 0.2 plus 0.05. So we've got 0.25. And we're still going to multiply that by 6 squared and divide it by 0.9. You could have worked out 6 squared at this stage, but say I'm just going to do one step at a time, keep it nice and simple. So after B for brackets, we got I for indices. So any squareds. So we've still got the 0.25 because we can't do anything with that yet. But 6 squared means 6 times itself. Okay. You can use a calculator, or hopefully you'll know 6 squared is 36. Then that'll need to be divided by 0.9. Right. Some people will say, well, BIDMAS, the D comes before the M. And that is correct, but because this is like written as a fraction, because everything is on top, it's like there's an invisible set of brackets. We have to do everything that's either on top or below the fraction before we can do the actual division. So we need to do the 0.25 times the 36 to give us 9. And then afterwards we can do the divide by 0.9. 0.9 to give us 10, which we can put down here. And that's the end of the paper. So I hope you liked it. Please give me the thumbs up, subscribe to the channel, change your notifications so you get updates as I load more videos. Let me know any comments you got, and hope to see you all again soon. Thank you.